Right, let's do this. Okay, don't need that. We'll pull up that. Here we're on polymorphism. So we just had the midterm, as you're all well aware. Midterm went, I think, pretty well. Just overall, looking at the class stats, there's quite a few of you, the majority of you, who don't have to take the final. So that's nice. And now, for those of you who did get at least one of DS and OP on the midterm, you don't have to take the final. There's no reason to take it. I won't even send you an email with the links to the final exam. You just take the day off that day. And once you're done with task 8, you're done with the course, baby. Finish up your tasks and get out of here. Enjoy your summer. So, which some of you have done. I think either 5 or 6 students are already done with the course. They're just gone. They can do their own thing now. So also quite a few students who are done with the course for worse reasons. They already failed, but that's besides the point. But this is the final deadlines. They eat a lot of students. So this is the second to last lecture of the course. After this lecture, we're 90% done with all of lecture content. I just got graphs on Tuesday, and then that's it for me. I'll be done at that point. Obviously, I have to administer and grade the final exam, but I'll be done lecturing. That'll be the last stream is next Tuesday. So let's learn polymorphism to do test 7. Test 7 is asking you to create this media library class with 2 notable methods. Populate library, which is calling the 3 methods that you have written or are writing. The expected deadline for task 6 didn't go super well. So some of you are still writing it. But calling those 3 methods from task 6 to get all of your songs and movies in this media library of rateables. So we have this situation where we're dealing with songs and movies simultaneously, and we want to somehow work with them, combine them and work with them together. So we kind of have this issue where we want to store them in a single data structure of rateables, and that's the big thing we'll talk about today. We're going to use polymorphism to be able to work with multiple types like that. You're writing one set of code. One media library class can handle songs and movies. That's our goal. And the functionality we'll get from this is top K rateables. So if I specify K is 10, that I'm asking for a top 10 list or a top 2 list or whatever K is. So this is going to return an array list of everything that's been added to the media library through populate library in order of their Bayesian average rating with 2 extra ratings of 3 with value 3. So the same spec as your Bayesian rating comparator specifies. So any way you can sort, we've seen multiple ways to sort things. It's up to you to, you have the task of custom sorting a custom object. You got to figure out just however you want to do that. And that's it. Those 2 methods. The rest are notes to kind of make some clarifications and help you out a little bit. The testing, you're going to test those 2 methods. You're going to call populate library, then call top K rateables, and make sure top K rateables gives you what you expected. And compare rateable array lists. So given 2 array lists of rateables, do they have the rateables with the same titles in the same order? And you only have to check the titles for this. I'm not asking you to go through the linked list of ratings and check all those. And the order matters here, so you can go index by index. So don't overthink this one. It's my big note on this. It's much easier than the utility methods. Your method, there's only one required, but I recommend you write both for movies and songs. This is much simpler than the one you wrote for task 6, so don't overthink this one. It's intended to be a pretty easy testing utility method. In fact, task 8 doesn't even have a testing utility method. I kind of phased these out in the last few tasks because you got the idea by now. You should all understand the usefulness of writing utility methods to help you write your tests. So I don't have to structure the last few assignments in ways to hit you again with them. Some of you still aren't using your utility methods, but that's besides the point. At this point, that's their problem. Okay. They're making the homeworks more difficult than they need to be still. The assignments are difficult, just inherently difficult, but some students will try to make them harder. or refuse to make them easier. Which is, I shouldn't word it like that. You're still learning, it's a thing. But when I say something like that in lecture so many times, it's just frustrating to watch when you're trying to help somebody and just nothing's getting through. Okay, so today we want to talk about polymorphism. And as always, in the 11 a.m. lecture, we're going to do this through live coding. So let's do it. So we do have a little bit of a start here. I have some code here: weapon, player, health potion, game item, and some sorting. 8 classes. This is, for the most part, there are a few changes. We'll go through these classes and just refresh what we have here. But for the most part, this is the code that we had at the end of the... actually, there's one change I want to make right away. I don't want player to extend game item. We didn't do that in lecture. I don't want it here. But for the most part, this is the code that we had at the end of the inheritance lecture. So let's just remind ourselves where we were with that. So we had a game item class. This controlled all of the location information for game items. It had X location, Y location, a constructor to initialize those values, a move method so we can move these things around, which is effectively our setters, set X, set Y location. But we don't want people setting them directly. We're going to move the object instead of setting. I mean, we have choices there. We could just have setters, but then getters for X and Y, a toString, so these print to the screen nice, and then 2 use methods, which will be the big things that we'll talk about today. Actually, we'll only talk about this one really. This is the use method we had in the inheritance example, and I'm adding a second use method here that takes a reference to a player, so we can have players that are actually using these items. Actually, I probably should. I don't think we saw the player class. How much of this did we see? Maybe I should code this one live. We can just walk through it. We got enough live coding to do today. All right, and then health potion would extended game item. It had a constructor to set X location, Y location, and increase, which was, you know what? Could I just... that was week 6. You know what? No, it's here. So what did we have? Lecture, player, extended game item. That's all we did. And I called it potency. So let's switch this to potency, just to match the last lecture. So I'm going to refactor, rename, potency. Ugh. You know, I knew that would happen. Let me just do it one at a time. Potency, 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 potency. So, lecture. Yeah. All right. I'm not gonna mess around with that anymore. But I am going to rewrite this because I hate this one. I got to change it. But we'll get to that. But use for player, let's just delete it so we have to implement it later. Get potency. A toString, we saw this toString. We overrode the toString method, but still called the method that we were overwriting and then added more functionality onto it. And a main method for a little testing. Weapon also extended game item, so we inherited all of the state and behavior of the game item class, and then we added this concept of damage to our weapons. We had this use method that just prints, simulates the damage that we're doing, and then a use method that takes a player. We'll write that one live too because we didn't see that one yet. Let's get rid of this one too. We'll write all that live. A toString that just completely overrides, and then we didn't use the override annotation here, but it still does override. The annotation just helps the compiler. And let's comment this one out because we erased that method. And then a main method to do some testing. And then finally the player class. We didn't see much of this, but at this point it's standard fare. It's same concepts we've seen before. Is a player, it's going to take max HP, set their max HP and HP. Actually, we did see this part. And then every player is going to have a damage factor. This is how much damage they're going to deal when they attack an enemy or another player. We don't do, we do have an attack. We don't do anything with that. I'm not going to use the attack method, but this is where it would be used. When you attack another player, they're going to take damage equal to the damage that this player deals. That's initially 4, and then we can set damage dealt, so we can change that through this setter. We don't have a getter for that. It's just going to affect what the attack method does. We have getters for get max HP and get HP. I actually want to add a setter for set HP. Public void set HP. My brain is just not doing it today. This dot HP equals HP. And I'll add my cap right here. We'll say math dot min of this dot max HP or the HP that it's setting. So we'll do our maximum check so nobody can set the HP higher than the max HP. If they try to, they're just going to get capped out at max HP. So we're using our setter for the reason we use setters, to do some sanitation of the inputs. Get HP, set damage, so getters and setters. A toString that's going to print out the health of the player, and also the supers toString, which we got rid of our super class. We are not extending anything. We're not going to do that. So we're just printing out the hit points. So HP over max HP, separate on 3 lines. Deleting the super call was changed that a little bit. Take damage, which is going to subtract their HP. This can go negative. We're just going to allow it to go negative if that's the case. And attacking other player we talked about, and a main method to do a little bit of testing. Let's run something here just to make sure I didn't break the code, because we have a health of -2. Yeah, we attacked twice and then printed, so we have -2. Okay. Yeah, P2 started with 6, attacked twice with the default 4, -2, makes sense. Okay, so that's our starting point. That's what we have for today. That's where we're starting today. And let's go in the health potion class and talk about a little bit of the implications of inheritance. So we talked about inheritance. We had a whole lecture on it. I said all kinds of good stuff about it. And one of the big selling points with inheritance that I said was that in the superclass, in game item, we can put functionality in game item, and then every class that extends game item gets all of the state and behavior of the game item class. So all of this state and behavior, all of this appears in both health potion and weapon. They just get it automatically. And if I want to add more functionality in game item, I can add it once, and every class that extends it gets that functionality. And this is really beneficial if I have, say, hundreds of different classes that extend game item, hundreds of different items that my players can interact with in the game. That's, that's something I can do pretty easily. I just add it to game item, any functionality to game item, and all those hundreds of classes get that behavior. So, which is a nice selling point. I like that selling point. It makes inheritance very powerful. But in my opinion, the most powerful thing inheritance does for us is it enables polymorphism, today's topic, which really makes, like, we would still use inheritance if it weren't for polymorphism, but polymorphism is the biggest payoff for using inheritance. So let's talk about what polymorphism is. So polymorphism, in a sentence, is if Oh, I didn't set it up properly. So health. Sorry, I got to back up a little bit. Health potion extends game item, and game item doesn't explicitly extend any classes, which means game item implicitly extends the object class. So we have this inheritance relationship between health potion, game item, and object, where health potion directly extends game item and indirectly extends object. So health potion has all the state and behavior of a health potion, of course, and of a game item, and of an object. So health potion has all of the state and behavior of all three of those classes. And when we have this inheritance relationship, we call this an is-a relationship. Because in a very real sense, a health potion is a game item. So if I have an object of type health potion, so if I say new health potion, this health potion really is, we're going to heal 100, really is a game item. And this health potion object is an object. It is those types. The health potion is all three of those types. This is a similar relationship to geometry, where a square is a rectangle, and a square is a quadrilateral, a square is a shape, because a square has all of the properties of a rectangle, but it also has some more properties. It's the same thing here. Health potion has all of the state and behavior of a game item, so it is a game item, but it also has some extra functionality. It has this potency functionality of this little extra state and behavior. But a health potion is a game item. So to finish this lineup, wow. IntelliJ. Careful using that autocomplete. Potion 1, implying that there's going to be more than one. There's actually going to be 3. So here's what polymorphism is. If an object is a type, it can be stored in variables of that type. So any object can be stored, of course, in variables of its own type, but it can also be stored in variables of any of its supertypes. So all three of these assignments are legal. I can store a health potion object in a game item variable because a health potion is a game item. And I can store a health potion in an object variable because a health potion is an object through inheritance. So I can store it in these variables. And we saw this very briefly in, man, I don't know the week numbers. I should add dashes here and say the topic too, so I don't constantly click around. BST took a comparator of A as a constructor parameter, and when we called this constructor, way down here, when we called this constructor, we would give it new int increasing or int decreasing or whatever comparator we want to give it, where A is integer in this case. We have effectively comparator of integer comparator equals new int increasing, which those types don't match. And I said, don't worry about it. Something called polymorphism. We'll get to it later. Well, now we're there. Because int increasing extends comparator of integer, it is a comparator of integer and can be stored in variables of type comparator of integer. That's why that assignment is legal. And that's what we're taking advantage of here. We're saying game item potion 2 equals a new health potion. This is a valid assignment because a health potion is a game item through the magic of polymorphism. And if you're doing this, if you're storing an object, a reference to an object in a variable of one of its supertypes, then and only then are you taking advantage of polymorphism. Where polymorphism, and I have to do the obligatory, poly means many, morph means forms, so polymorphism is many forms. Health potion has many forms. In our case, in this example, a health potion has 3 different forms it can take. It can act as a health potion, a game item, or an object. And that's polymorphism. We got to spend the rest of the lecture talking about the implications of this and what effect that has on our code. But this right here is polymorphism. When I take a health potion and store it in a variable of a different type, one of its super types, that's using polymorphism. which is bending one of the rules that we talked about right from day one, that if I have a variable of type game item, that variable can only ever store a game item. I think I use doubles. I have a variable of type double. That variable can only ever store a double. I can't assign a string to it or anything. That's still true, but we are bending it a little bit because I'm not literally storing a game item, but since a health potion is a game item, I'm still storing a game item in a variable of type game item, but that game item happens to be a health potion, which is a game item. All right, does missing code block mean I forgot to add a stack frame? Oh my goodness. I wanted to get through my spiel before I read that question, because I didn't want to put that in the middle of my intro to polymorphism, but I don't know how to answer this one. It means you're missing a code block. Why would missing a code block mean you're missing a stack frame? Missing code block means you're missing a code block. It means you forgot to add a code block. Code blocks and stack frames are different. But if your only feedback was missing code block, that I consider that a minor mistake, and you still pass the quiz. But yeah, it means you're missing a code block. So it's just weird because it's answered in your question. That's how I don't fully know how to answer it. But code block. This is a code block. This is a stack frame. So it means you missed your code block. And this is when both of the data structures quizzes had code blocks because you had variables being declared inside of a code block. So you had to have your dash box. You're supposed to have your dash box. But I did consider that a minor thing. So missing code block basically meant good job. And then if you actually got the good job, that means you did excellent because you actually remembered your code blocks, which very few students did. Most of you all didn't have your code blocks. And when most of the students in a class make a mistake like that, I consider that my mistake. I gotta fix that in lecture somehow. I gotta get code blocks across better in lecture because I think there's only maybe 6, I don't even know if it was that many, students who actually did have their code blocks. So if you did have your code blocks, you're doing great, good job. You're actually following along the material and remembering everything. For those of you who missed it, I consider that my mistake. But yeah, the code blocks and stack frames are definitely different things. And it's tougher, not to go too far on a tangent with this, but it's tougher because I consider code blocks a 115 topic. But since 115 is taught in Python and Python treats code blocks differently, you don't actually trace your code blocks in Python. So when we get to Java, I'm just like, here's code blocks, ain't that cool? And it just comes and goes really quickly. And then by the time you actually get to your quiz, it's been so long since we really talked about code blocks. I think that's why most of y'all are forgetting it. Because it's been a long time. Plus, you're focused on the OOP and the data structures content, which is what I want you to focus on anyway, so it's not a big deal. I wanted you to focus on the actual 116 learning objectives, so I don't care as much about code blocks. But I don't know what to do about that in the future. I think code blocks might just have to be promoted to a 116 learning objective. Since they don't cover it at all in 115, it kind of has to be covered in 116, even though the concept of code blocks is a 115 concept. But just because Python's weird, I don't know, it's a weird thing. But yeah, that's my explanation for that. But yeah, code blocks are different from stack frames, which is kind of weird because a method is technically a code block, but it's a special code block that defines a method, which creates a stack frame. Okay, so all these are valid assignments, and we talked about polymorphism. That's polymorphism, baby. Like, that's it. So we got to spend the rest of the time talking about the implications of this. And and there are upsides. I tease this by saying polymorphism is the biggest payoff to setting up inheritance. And we will get to the payoffs, but I think it's such a big selling point. I think polymorphism is so powerful that I'm actually going to start off with a downside of polymorphism. So the downside to polymorphism is you can only access the state and behavior, and all of our state's private anyway, so I'll just say behavior. You can only call the methods or access the behavior that's known to the variable type. So with potion 1, I know about everything. I can call, for example, get potency, and that's going to return the potency. Let's print it to the screen just to get rid of that warning. All right, so I can call get potency from potion 1, but if I try calling get potency, let me do this one at a time actually. If I try calling get potency from potion 2, I'm going to run into some problems. I get an error. I can try to run the code, but it's not going to run. It's not going to compile. And it's going to say, I don't know what this method get potency is. I have no idea anything about this get potency thing. Which seems weird, because if we look at the code, we know that we have a health potion stored in potion 2, and health potion has get potency right here. The issue is that you can only access the methods that are known to the variable type. The variable type is game item, and if we go to the game item class, there's nothing in here, nowhere in here that we're going to see a get potency method. The game item class does not know about the get potency method. So if we call this through a game item, we can do our search. We'll look for get potency. We don't find it. We go to the superclass, which is object. Object, I'll tell you, it doesn't have a get potency method. It wouldn't make sense. It has toString equals hash code and a couple others. Definitely not a get potency. It's not something that every object in Java really needs or wants. So I can't call get potency from potion 2. I can't call get potency from potion 3 because object definitely doesn't know about get potency. So these do not compile. Does not compile. Ugh. These don't compile because those variable types don't know about the get potency method. Even though they do, in fact, store health potion objects, those health potion objects do have a get potency method, and they would happily call that method if given the chance. But they don't get the chance because the variable itself blocks the call. The variable says, I'm a game item or I'm an object. I don't know about no get potency method. That's ridiculous. I'm not doing that. So the method, even though it's there, can't be called because of the type of the variable. If I try to get x, this one, similar situation, except get x is known to the game item class. So game item, the potion 2 variable can happily call get x. Potion 1 can happily call get x because it inherits it from game item. But potion 3 of type object can't call get x. This does not compile. Can't do it. Not allowed. And if we go one step further, potion 1 dot, I'm going to explicitly call toString. It'll be called anyway, but just to make it explicit, it's grayed out because it's implicitly called anyway. Potion 1, potion 2, potion 3. If I call toString, this is perfectly fine. This is known to the object class. Game item inherits it from object. Health potion inherits it from game item, which inherit it from object. So all three types know about the toString method, so I can call toString from all three of these. So which method is allowed to be called depends on the type of the variable. And that's the only thing the variable does. It determines what is allowed to happen, what is allowed to be called. What happens when the method is actually called, though, depends on the type of the object, which is the way it's always been. I was very careful. Every single memory diagram we've ever done, I was very careful to look at the type of the object. And I'll do that again when we get to the memory diagram for these. But which method is called, so health potion overrides toString, for example. That's the most useful one we can look at here. Overrides toString, which calls the super toString and adds this health potion potency. This part right here is only known to the health potion class. But when we call that toString method from our game item and object variables, we still get the health potion functionality all 3 times. So which method is actually called still depends on the type of the object. So the type of the variable determines what's allowed to be called. The type of the object, did I say that right? The type of the variable determines what methods are allowed to be called. The type of the object still determines what method is actually called. So even though we're calling potion3.toString through a variable type object, that checks if the call is valid. But when toString is actually called, we still go to the type of the object to determine what's actually going to happen for that call. Which is the most important thing to know about polymorphism in terms of your tracing quizzes, but it's the summer. We don't have a polymorphism tracing quiz, so it's just something you have to know for your coding. What behavior you're going to get in your code when you're writing code that uses polymorphism. Or else I would go on a huge rant. I'll do a mini version of it still. Huge, long thing about taking your quizzes and how to pass the polymorphism quiz. The final exam quizzes, for those of you who will be taking the final is going to look just like the midterm. It's going to be different versions of each quiz, so you're going to get different problems that you actually see, but they will assess the same exact material. So they're going to look very similar to the midterm. It's going to be the same thing, superclass constructors, which method is called, but all of the objects will match the variable types, just like they did for the midterm. That'll be true. I won't mismatch the variable type and the object type. That would be polymorphism. Polymorphism isn't going to show up on the final. We just don't assess it in the summer. Let me rephrase that. We don't assess it through a tracing quiz. It's assessed on task 7, of course. So you won't have this issue. But if we had a tracing quiz on polymorphism, the trick to it is to completely ignore the variable types. Because the variable types have zero effect on the way your code executes, and what happens in memory has absolutely zero effect on it. The variable type only determines if assignments are legal and which methods can be called. But both of those things are compile time checks. If your code is running, that means you already got past all the compile time checks. The compiler's happy with your code and compiled it just fine, and your code's running, which means the variable types don't matter anymore. Variable types do not matter when your code is running at all. That's why we don't even put them on our traces. We don't put variable types in our traces ever, at all. We do put object types on the heap because those do matter. Those do change the behavior of our code. Variable types don't. They only are there for compile time checks. Everything to do with strong typing is checked by the compiler. That's why we don't have strong typing in Python. There is no compiler to do the checks for us. Okay, so all these are valid. It's polymorphism, baby. Okay, so, but why? Why would we ever do this? Seems like a silly thing to do. So we take our health potion and we stuff it in a variable type game item, which all it does is restrict what we can do. We now can no longer call the get potency method. Seems like a really dumb thing to do, and admittedly it kind of is. You would never actually do this, these 2 lines here, you would never actually do this. You would never just say game item potion 2 equals new health potion and directly assign your object to a variable of one of its super types. Because all you're doing is restricting what you can do with that object with no gain. You didn't benefit at all by doing that. So why even talk about polymorphism? Well, good question. I'm glad you asked. So the answer is to simplify other classes. And I don't think I have it in here at all. Okay, good. I'll just, no, I don't want to put them above my getters and setters. Put it right here. So in the player class, the player is going to be using these items. So for a player to use an item, what I have to do is write a method for it. I'm going to have a method that returns void, and I'm going to have a use item, but I have health potions and weapons. Let's start with health potion. I'm going to say use health potion. This takes a health potion. Oops. Health potion potion. And I'm going to call potion.use. Let's just call it potion.use for now. I actually want to do something different, but I deleted that code. We'll set it up later. So potion.use. Okay, cool. But then we also want public void. We also want to be able to use weapons. So I'm going to write use weapon, 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 weapon. Sometimes Java is very repetitive. And use weapon. So I'm going to need these two methods. One that takes weapons to use a weapon, one to use a health potion that takes a health potion. And once I have hundreds of types, I have to have hundreds of these methods. I'm going to write a new method for every single type of object that a player can use. And hopefully you can see how tedious this is going to get. And every one of them is going to do the same thing. It's just going to call the use method. So what can we do that's better? Well, we can embrace polymorphism, public void, and instead of writing a use method for every single type in our game, we're just going to write a use item method that takes a game item and calls item.use. Now I don't need these methods anymore. I don't need a method for every single type. As long as all of the types that I can use extend the game item class, I can call this use item method on any of them. So if I want to create a player and say use a health potion, I have my potion. I can have a weapon. Sure, we'll keep damage 100. I can say p1.use potion. What is it? Oh, use item. Use item potion, p1.useItem weapon. So what I have here is one method that can be used on multiple different types. I have this one single method that can be used for health potions, weapons, and anything else I create that extends game item. As long as it is a game item, this method can be used for it. So this is why we use polymorphism. It's not to simplify code that looks like this. It's to simplify other classes. So we're not using polymorphism to simplify the health potion class or the weapon class. We use it to simplify the player class, which is going to interact with game items. So I write one method to game item, and this one method can be used for health potions and weapons. That's the advantage. This is where we really get the power of polymorphism, because I can write methods that are much more flexible than they would be otherwise. Just like our comparator, our BST constructor, or we're going to talk about this later, I'll jump to it quick, is in the insertion sort constructor too takes a comparator. As long as I give this something that extends comparator, it can work with that type. I have one constructor and one instance variable, and these can work with anything that extends comparator. So I don't have to write a new insertion sort method or class for every type of comparator you could possibly use, every type of way you could sort your values. I'm just going to write one insertion sort, have it work with comparator, and then all my comparators will extend comparator. So this int decreasing is a comparator. and I can use it in this constructor call. Give it to comparator of t, where in this case t is integer. Int decreasing extends comparator of integer. Everything's valid assignment due to polymorphism, and everything's great. We can write much more generic code, much cleaner code, and write much less duplicate code. We're not going to duplicate our code nearly as much as we would. And this one's pretty simple because it's a lecture example. I'm keeping it simple. Item.use, we're just calling use. But this can be a lot more complicated. In the fall and spring semesters, we have a project where you build a whole game engine in a game, something that I just thought it wouldn't really fit in the summer class in 6 weeks. But they build a whole game engine, and part of that game engine is a physics engine to determine how objects move throughout your game. It'll account for gravity, so it'll update the velocity based on gravity, and then based on an object's velocity, it'll update its location, and then also detect collisions between objects using their hitboxes. And all of that code is coded to the game object class, actually dynamic game object and static game object. We don't have to get into all the details. It'll work off the game object class and do all of that work with game items, or game objects in that case, game items in this example. So when you write your physics engine, you write the physics engine one possible time, and then for every single game object in our game, that physics engine will work. And by the end of the semester, we have like 15 different game object types, things that extend game object. We have our enemies, projectiles, players, walls, towers. We have all these objects, all these different things, classes that extend game object, and they all work with our physics engine without having to update the physics engine every time. We don't have to go to our physics engine and say, well, now we have projectiles. Here's how projectiles move. Now we have this new enemy type. How does this enemy type move? And add another loop. Okay, now go through all them and update their velocities and their locations and detect their collisions. We don't have to do any of that because we just work with game object. In the physics engine, you write it once. They write it once in task 1, and then a little later, and in the inheritance task, they add gravity to it. But you write that code one time, and you're done. That's it. It just works with every type, even types that don't even exist at the time when you wrote the physics engine. That's the power of polymorphism. We would never be able to get that project to work without polymorphism. But there's one other thing, there's one more thing we can do with polymorphism. So one is assigning, just to wrap this one up, is assigning objects to variables of one of their supertypes, which I said you would never do this. You would never do this because this line of code is kind of silly. But when you have this effectively same exact thing that I have highlighted here, but across a method call. So I have game item equals potion, which is a health potion. When you split that up across a method call, that's when it gets really useful because now you can simplify the methods that you write. So this game item variable called item, this will store health potions, it'll store weapons, but that's fine because those are both valid assignments. And when I run this, the functionality we actually get, that's because I started writing a method, but then I started writing an instance variable, but didn't finish the line. The actual behavior that we get is still related to the object type. So when I use potion and use weapon, I get item used. Apparently potion isn't overriding the use method right now. And damage dealt 100, that's the use method for the weapon. Is health potion really not overriding? Oh, because I deleted it, didn't I? Why would I delete that one though? Maybe we never had it. So that's the behavior. That's polymorphism. But there's one more thing. Aside from storing values in variables of one of its supertypes, we can also use this with data structures. if we have a data structure of a super type, we can have multiple different types of objects in our data structure. So if I want an inventory system, for example, have it as an empty array list initially. If I want an inventory system, I can do that. I can create an inventory of game items as opposed to storing, like, what we would have to do is weapon. Here's all my weapons. Here's all my potions. I'll just give them numbers because I'm going to delete them anyway. Instead of having an array list for each type, which is what we would have to do without inheritance and polymorphism, this is what we would have to do, and then manage that inventory. And then once we have, by the time we have like 5 different item types, this is going to be a huge pain in the ass. We're not going to want to do this. Every method that you write that interacts with your inventory is going to be really complicated. You have 5 different types. You're iterating through 5 different arrays every single time you have anything that interacts with your inventory. Huge, huge pain. But with polymorphism, we have one inventory of game items, and now things get pretty simple. We're just working with game items. Oops, let me see if I can get both on the screen. So now if I want to work with this, public, let's do void pick up item. Another method that's going to take a game item and this.inventory.add that item. And one more method, I want a public void, just this is mostly setting up for the memory diagram. Public void use all items. But actually building the game, you would say like use the item at index whatever, or use this specific item, use the currently selected item, or something like that. We're just going to write a method that uses all items. That's all I need to be able to make the points I need for the memory diagram. Then for game item in this.inventory item.use. We'll revisit this. I want to change this a little bit. Some of the code that I deleted, I want to code live, and then we'll change this. But this is going to iterate over that inventory and call the use method. Use is known to the game item class, so we can call it through the game item variables. So that's a legal call. And then what actually happens when we use it is going to be determined by the actual items that we're using. So actually, let's change this to pick up item. And then use all items. Actually get rid of all this too. Again, just thinking ahead to the memory diagram, starting to set it up for the memory diagram. So that's all legal. We can mix types in our data structures. We can have methods that take super types and then actually take in the concrete types. I didn't introduce that terminology. Oh, because I didn't talk about. That's the next thing we're going to talk about. So this is all legal. This is all the power of polymorphism. Methods coded to the super type. Data structures that take the super type. We can finally mix types. This is something we take for granted in Python. Python just lets you mix types in your lists and doesn't complain at all. We have a little bit more work to do in Java to finally be able to bend the rules a little bit about an array list can only store game items. Still true, but health potions are game items and weapons are game items. So perfectly fine. So we bend the rules a little bit and get 2 different types in the same array list. We can finally do that. That's what you're expected to do for task 7, creating an array list of rateables that can store both songs and movies. So we finally get the payoff of setting that up back in the inheritance task, that songs and movies are both rateables. We had some payoff. They both got the Bayesian rating method, all that functionality. But now we take it one step further and start mixing them in our array lists and having methods that work with rateables that return an array list of rateables that has both songs and movies. That's pretty pretty neat. Something we can't do without polymorphism. Okay. So I want to add that method back in that I deleted before. We had a use method. If you saw it quick, it's a use method that takes a player. Because right now we're just simulating using methods using print statements, and that's kind of boring. That's not fun. So I want to add, I want public void use. I want a use method that takes a player, which is the player that's using the item. That's what I want. But I don't want to give this a default behavior. Like for use, like this was actually kind of awkward too. With use, we gave it default behavior of just printing item used. I don't actually want that. I don't want to give any default behavior to these methods at all. And by the way, this what I'm about to talk about, these next few topics, these are technically inheritance topics, but the inheritance lecture is already so stuffed, I can't fit them in that lecture. There's a bit more extra room in the polymorphism lecture to cover these topics, so they just get pushed to the polymorphism lecture. But polymorphism, it's if you're storing an object in a variable that doesn't match its type, you're using polymorphism, and that's it. Everything else is inheritance or just not even related to OP. So I don't want to give any default implementation. That default use method was pretty meaningless. So what I'd like to do is just say, yeah, there's a use method. There's actually two use methods. It's overloaded as long as they have different parameter lists. This is fine. But there's two use methods, but I don't know what they're supposed to do. I just want them to exist. They will exist, but it's up to the classes that extend game item to actually decide what happens. It's up to the weapon to decide what happens when it's used. It's up to the health potion to decide what happens when it's used. So I don't want to give any default implementation. There's no meaningful default implementation. We just made up some random crap when we wrote the use method the first time. So what we can do is call these abstract and make abstract methods, which are methods that don't have any implementation. So these methods, we define the header, that's the return type, the name of the method, and the parameter list. We define the header, but we do not define what the method is supposed to do. We don't give it a definition. So we declare the method without defining the method is the terminology we use. And I'm getting errors that's saying we can't do this because once you have at least one abstract method in a class, your class itself has to be abstract. Which are, for our practical purposes, what this means is I can no longer say new game item. I can't create a game item. Before game item was abstract, so if we back this up a little bit, get rid of our abstract methods, we can technically create a new game item. It's a class. We can create objects of classes. That's why we write classes, is to create objects of them. But once it's abstract, we can't. This is an error. We cannot instantiate an abstract class. We cannot create an object of an abstract type. It's not allowed. Can't do it. Which is fine, because we don't really want a game item in our code. We don't want anywhere in our game, when somebody's playing our game, we never want there to be a game item. That sounds weird. But like, you don't want a player to like pick up a game item and have a game item in their inventory. That doesn't make sense. We want them to have a health potion in their inventory. We want them to have a weapon in their inventory. And actually, I'd argue that we don't even want them to have weapon in their inventory. I think weapon should be abstract too, because what the hell's a weapon? I don't know. I want the player should have a sword in their inventory, maybe grenades, a bow and arrow, landmines, rocket launchers. But a just weapon? What is that? We've been using it in multiple lectures, but I don't really like that we just call it weapon. What's a weapon? I don't know. I always think of them as swords when I'm doing the lecture examples. So So we're just going to leave those abstract. And then what should happen when an abstract method is called is an issue. And I don't know. I don't know what should happen. Java also doesn't know what should happen. And to avoid that, that's why you can't create objects of abstract types, because you might be tempted to call one of these abstract methods, and you're in a situation where you're calling a method with no definition. What's supposed to happen? I don't know. And you could speculate, okay, well, they're void. It just shouldn't do anything if there's no definition, which is fine. That's fair. But what happens if they have a return type? What if they return an int? You can say, well, they should probably return 0, right? What if they return a string? Well, maybe the empty string. We'll define defaults for all these. What if they return a player? Well, you can return null. But Java says, no, if it's abstract, you're not allowed to call it. And if you create an object of an abstract type, you might be tempted to call it, so we're not going to let you do that either. And then I'm getting errors. I should have errors in Health Potion too. Now I'm getting errors because when you extend a class, when you extend an abstract class, you have an obligation to implement all of the abstract methods of the type that you're extending. So since I have these use and use methods, I have to implement them. So I'll use my override. We'll get these methods in there. So public. So now in Health Potion, I'm extending game item, and now I say, okay, this is what I actually want the use method to do. So public void use, that takes no parameters. I'm just going to have my print statement. Doesn't really matter what we do here. Health Potion used. I can put a space in between here because this is printed to the screen. Override. And then the next one is the one we'll use in our memory diagram. Void use, that takes a player, called player. And then this is where I actually want some functionality in the Health Potion. I'm going to do player.setHP. This is why we created that setter earlier. Set HP to player.getHP plus this.potency. So we're going to heal the player, and then the setter, the HP setter, is going to check if we went over max HP to get that check in there. Okay. So now we've satisfied our obligation, and everything's fine. Except weapon. Weapon, we did not satisfy this. We have the use method, but we don't have our use method that takes a player reference as a parameter. So we have an issue. We have to implement that method. And I kind of lied a little bit. You actually don't have to implement all of the abstract methods. You do have a second option, and that's to be abstract yourself. So I don't like that weapon was a concrete class. So let's fix that. Well, now a weapon is abstract, and this is perfectly fine, except we're trying to create a new weapon here. Let's just get rid of this main method. We're not going to use it. We're going to have an issue down here too, but we'll fix that one later. And let's create a new class. And let's actually do the sword. This is going to extend weapon. So this is an actual concrete a weapon that you can actually hold and have. And we need a few things. We need our constructor, because we have to call the super constructor. Sword, let's take no parameters, I guess. Super, we'll just start at the origin. Mostly because I don't feel like messing around with stuff we've already talked about. And let's say a sword is going to do 30 damage. And then we also have to implement all the abstract methods if we want this to be a concrete class. So let's implement that use method that takes a player. Use player dot set damage dealt to this dot get damage. Ooh, I'm concerned that's why is that not giving me the autocomplete, which is usually gonna indicate that I did something wrong here. So weapon does not have a get damage getter. Well, at least that's an easy fix. Void int get damage. Sure. Return this dot damage. It actually didn't have the getter. Easy fix. So we're going to set the player's damage to this sword's damage. Now everything's perfectly fine. Almost. So I said we'd fix this, so let's go back here and fix this. This is going to be a sword now. Constructor takes no parameters. And we can still store it in a weapon. I'm going to leave that because whatever. Who cares? That's a valid assignment. And pick up item. I can actually change this to game item. Let's do that for the memory diagram. I can change this to game item. Doesn't matter. Because the only thing, we're not doing any sword specific stuff. We're not doing any weapon specific stuff. We're only doing game item stuff with it. Every method we're calling, everything, usage that we're every usage of this, we're only doing game item stuff. Pick up item takes a game item, puts it in your inventory, which is of game item types, and then we're calling use all items, which takes takes everything in the inventory as a game item and calls use, which is known to the game item class. So I can actually get away with this. There's no reason to. In the real world, why not just put sword here, just in case later on you want to use some sword specific functionality. But we're not here, so we can get away with this. Let's do it. Okay. Let's give this player some more HP. Just because our numbers got bigger here. Okay. Okay. What are we missing? I don't know if we're missing anything. I think we're ready for a memory diagram. Interfaces. Interfaces and why would we use abstract. I didn't even explain why we use abstract methods. I kind of did. It was kind of implied, but let me make it explicit. We use abstract methods when we don't have any default implementation for the method, but then, like, well, why not just not do it? Like, this code is fine if I just delete this method, because health potion has to have a use method. It doesn't override it anymore, but it has a use method. And weapon has a use method, which sword inherits. So all these objects still have a use method that takes no parameters without putting it in game item. If I don't have any implementation, any code that I'm sharing among all these classes, which was the original point of inheritance, why even put it in the game item class? It doesn't make sense. Like, why not just delete these? And the answer is this is going to break this code. Because that use method, oh, and I wanted to update this. So this, I want to call the use method in use all items that takes a player reference, and we have a player reference in this. I'm going to pass the player that's using all the items, which will be the keyword this, will be a reference to that player that's using all the items. I want to pass that to the item and tell that item that this is the player using the items. But we get an error here because the use method is no longer known to the game item class. Even though everything in this inventory, we know from looking at our code that it will be an object that has a use method that takes a player. That method exists. This can be called. In other languages, without strong typing, this code just runs fine. Everything's fine. But since the game item class doesn't know about the use method, it's not a valid call. So we would use abstract methods. We use abstract methods when we don't have a default implementation that's meaningful for all the inheriting classes, but we want to make sure that method is known to the superclass so we can take advantage of polymorphism. So in those cases, we create abstract methods in the super type and say, hey, y'all inheriting classes got to give some implementation for this, but I need to know that this method exists. So it's creating a guarantee that if you're a game item, you will have these methods. I don't know what they're going to do, but you're going to have them because somebody's going to call them through variables of my type, so you better have something ready for them. This makes the most sense in our comparator. So we'll shift to this one, and then we'll get to our memory diagram. In our comparator, it always bugs me that compare, I mean, it's the way we have to structure the course, the way the order of topics and everything goes. But it always bugs me that compare isn't abstract. This should really be an abstract method. So this should be an abstract method because having the default return false is meaningless. You never ever want this implementation. You never want a comparator, a compare method that just returns false. That's bad. It's not what you want. And then we had some issues. This is where I talked about the override annotation and making sure that you're actually overriding that return false. Well, if you make that an abstract method, now that it's an abstract method, if I do ints and I have something wrong here where I'm not actually overriding, even without my override annotation, I'm going to get an error that says, hey, you inherited an abstract method. You better implement that or else you're screwed. So we have to implement that. And then if we have our annotation also, we just have an extra check. There's even more checks saying you better actually, better implement it and make sure we implemented it. It's very hard to make a mistake if you're doing all this. If you're using abstract methods and your override annotation, you're never going to have a mistake where you intended to override a method but didn't. But we can take this a step further, and now we can get rid of our comment too. That comment lies now. Comments sometimes lie, code never lies. Now we have a situation where we have an abstract class with nothing but abstract methods, and only one in this case. And when that's the case, we can take this a step further. Instead of making this an abstract class, we make this what's called an interface. An interface is like a class, except it only has abstract methods. So now my public abstract, it's going to yell at me, not yell at me, but IntelliJ is going to say, hey, you don't have to tell me this is public. Interfaces can only have public abstract methods. So this is redundant. You don't have to tell me. It's fine. So we can actually delete these and just put the method header. And it's implied that it's both public and abstract. And interfaces can't have anything else. They can't have constructors or anything. Any other, I have to qualify this because somebody called me out in lecture one time. It can't have any other non-static stuff. And also there's the keyword default. So we can have an implementation if we use the keyword default, but I don't want to go down that rabbit hole. Aside from default as the only exception, this is the only non-static stuff you can have in an interface are abstract methods. Now you can do something like this. You can do like int x equals 7, and you won't get errors, and that sure as hell looks like an instance variable, but it's not. In fact, like if you try to make this private, you're going to get an error because it's not an instance variable. You can't make it look like an instance variable, but it kind of does. But if we do the same thing we saw with the method, if we do public, it gets grayed out because it's saying it has to be public, of course. That's why I get an error when it's private, because you can't have anything private in an interface. It's not allowed. Not allowed here. It just says not allowed. It doesn't even say why. It's just like, don't do that. What are you doing? You're in an interface. Why are you creating a private anything? It's public. It's static. That gets grayed out because it's implied that it's static, because you can't have a non-static variable in your interface. That's insanity. And it's also final. So you can have public static constants in your interfaces, and that's fine. You can also have static methods like a main method, and you access that variable through the interface itself. Because it's static, it belongs to the interface itself, not any objects on the heap related to that. Let me print this to the screen just to get rid of the error. And this will print 7 to the screen. Oh, yeah, we have to fix this still. It'll print 7 to the screen. We'll run it in a second, but I got to finish my talk about interfaces. But so this is public static final. So if you type something like this and you don't get errors, don't say, oh, Jesse lied to me. You can have instance variables and interfaces. No, you can't. You can't have instance variables. Um, you can't have constructors. You can't have any methods with definitions, with the exception of the keyword default, which I'm not going to talk about. All you can have, the only meaningful thing in an interface are the abstract methods. And when you have an interface, you don't extend an interface, you implement an interface. So int decreasing implements this interface. It doesn't extend it. Implements. Unless you have an interface implementing another interface, the interface extends another interface. For reasons, it's nuanced, it makes sense. But now that the code compiles, we can run this and print 7 to the screen. Print 7. But it's a static variable. All that to say, interfaces, abstract methods only. Okay, so why interfaces? I always like to explain why we do the things we do. So why interfaces? Why not just make this an abstract class and just don't give it a constructor or instance variables? Why go the step further and restrict ourselves with this interface? And the reason is, the reason is, I already did that once today, didn't I? The reason is you can only extend one class. Every single class you write will extend exactly one class. It either extends something explicitly, sword is clearly extending weapon, or implicitly, game item is extending object. But it's always going to extend exactly one object in Java. But you can implement as many interfaces as you want. If I want to implement my comparator, I don't know, comparator of players, I don't know. I can do that. And if I want to implement another one, say serializable, which is a built-in comparator, I can do that. And I can just have a comma-separated list of as many interfaces as I want. So you can only extend one class, but you can implement as many interfaces as you want. So if you want to use multiple inheritance in Java, your only option is to use interfaces. So that's where the advantage of interfaces comes in. That's why we would use interfaces. If you want to inherit from multiple things, all but one of those things better be an interface. And we saw that briefly when we saw the ArrayList class. I didn't talk about it at the time because it was just too much. But ArrayList extends abstract list. That's its one extension. You only get one. But it also implements 4 interfaces. So it implements a list interface, which has all of our add and size, and all the methods we actually use are in the list interface. Random access, clonable, and serializable. So we can do these other things with it. We can write methods that take a random access object, and that can be an array list, and that's fine. And this is from last lecture when we had the read all lines returned a list. It just meant that it returns something that implements the list interface. And I believe read all lines actually does, in fact, return an array list. But since the return type of the method is list, it's just saying I return something that implements the list interface. ArrayList also implements the list interface, so that's fine. But we throw in the ArrayList constructor to get that ArrayList variable. Just more of a side note, but just to explain something that came up in the last lecture. Okay. I don't think there's anything more I want to do here. I think we're ready for the memory diagram. Oh, and we're pretty far into lecture too. So let me clean some stuff up, or do I want to just go into... What? Why is it yelling at me? Let me go into the tracing tool and just clean it up here. So here's game item, and then I'll just start deleting everything we're not going to use. I did set this up, right? We have inventory, picking up 2 items, and then using them. Let's get rid of some extra lines here. What order do I want? Let's do game item, health potion. All right, so just This will take a minute, but let's get this all set up. We'll get all the code in there, then I'll just start deleting stuff. Weapon, then sword. I did more code than I usually do for this trace, so it's not all gonna fit without scrolling, but we'll do the best we can. I usually trim it down a lot for lecture, but since I'm live coding it, not gonna. And player. Okay, so what aren't we gonna do? We're not gonna attack anybody. We're not two-stringing anything. We're not using these commented out methods. We're not using items directly. We're going to use them through inventory. We are going to use from inventory. We're going to set damage. We're going to get HP. We're going to set HP. We're not going to get max HP actually. Okay, there's the player class. We're actually ready for full screen, and we're not printing anything to the screen. Okay, we can get rid of our imports and package declaration. Sword looks good. We're gonna use everything in sword. We're not two-stringing. We're not using. We are getting damage. Definitely don't need this main method that's not being called. Not printing to the screen. We are using a health potion. Nobody's getting the potency from outside of this class. We're doing direct access, not getter. And game item, keep the abstract methods. Get rid of two-string. Get rid of all this location stuff. And we're good. Okay, so we got a good amount of scrolling still, but we'll live. Guess we can get rid of the override annotation too. As much as I like them, it's not necessary. Okay, so let's trace this thing. All right, every trace always starts with the main method. And you might get sick of me saying things like that, but there were students on the midterm who submitted traces without a main method. Like, not just without a main method, but none of the variables were, like, they didn't accidentally call it global or something like that. Like, they just straight up didn't have it. Maybe they have other issues, like just not paying attention to anything, but there's a reason I repeat things so many times. It's so that I know that those students just didn't pay attention to anything. I don't like when students fail in general, but I want to make sure that I did everything I could to give them every opportunity they could. So when they forget their main method, or not forget, when they just don't know to put a main method, I know they just didn't listen to the hundreds of times I said that. All right, damage dealt. So a lot of this, so with OP, you know this from the midterm, there's just a lot of setup that we have to do. So I got to get through these 3 constructors and picking up the items. It's use all items that we're really interested in for this trace. That's where I get to talk about polymorphism. So let's get through the rest of this. We have our player. I'm going to go through it quick, so hopefully I don't make mistakes. I made a few in the other one. I caught them, but if there were any that I didn't catch, I wouldn't know. So I might have had some mistakes in it. Try to be flawless here while going pretty quickly, so we're not bogged down in all the details. Okay, so max HP, P1, okay, everything's good there. We don't extend anything, so no extra variables. We have inventory. And inventory gets initialized right away, so let's do that. So we have an array list, no constructor, no variables, empty array list, OX200. Then we run the constructor. We have max HP. Only the parameter goes in the constructor. That mistake I see a ton on the midterm. as expected, as I've talked about multiple times in lecture, but I did count that as a minor mistake anyway, so not too worried about it. This dot max HP, forgetting the main method though, like at a glance, I know you didn't study tracing at that point. And damage del equals 4 hard-coded. So this returns. And it's very few students, and I suspect that those students just literally don't watch lecture. Health potion. This it's going to be OX300. Health potion. Health potion is going to have. Let's scroll, and notice even when I know, like, I could probably do this whole trace without even looking at the code, but I'm still going to look at every piece of the code and just do things one step at a time, because that's what I encourage you to do on your traces. For most of you, probably especially most of you who are watching lecture live or even watching the recording, probably don't have to take the final, and you might never do another trace again, so it doesn't, but it doesn't matter so much. But I like to do it one step at a time, very slowly, methodically, because that's what I recommend you do on your traces. It's very hard to make mistakes if you're just methodically going through every single piece of code that's being executed. So we have potency. We also extend game items, so we get X location, Y location. X location, Y location. And then we're ready to call the constructor. So we have 3 parameters here, which do happen to match the instance variables this time. Not always the case. Potency. And then super of X location, Y location. So we have a game item constructor. This is still a reference to the object that's being created. 2 constructor calls to create 1 object. X location, Y location. I didn't get my arguments in here. Arguments are 0, 0, 100. And the 0, 0 get pushed to the super constructor call. Super constructor is setting X location, Y location. This dot X location equals X location. Y location equals Y location. This returns, goes back to health potion, which is going to set potency. And this returns, I forgot my return arrow again, returns OX300. So that's the health potion. Yep, just making sure I got everything. That's the health potion, and then we have sword. And this the trace from the quiz. I mean, yeah, they're all kind of similar, but a little different each time. They don't get too different because, like, I'm testing the same concepts every time. In lecture, I show you the same concept over and over, and then I assess that concept. So they're all going to look very similar. Which is why I always find it weird when students ask for like sample quizzes. I'm like, the quiz is going to look just like what I showed you in lecture. It's going to feel like the same thing over and over. But I'm glad that it's looking the same over and over to you, because that means you're paying attention. Because some students looking at their traces for the midterm, I swear they never have done a trace until the midterm. I do suspect that a lot of students do that. Never do a practice trace ever. They never open the tracing tool and just try to do a trace until it's time for the exam. Which, I mean, I don't know if they're expecting better results. Like, I don't know. Sword, no instance variables. Weapon has a damage instance variable, because they will act like the first time they've ever seen it. Weapon extends game items, so we have to go through another step of inheritance. X location, Y location. And I think I already said it earlier in the lecture, but for those of you who are taking the final, don't be surprised when it looks just like the midterm. It's going to be different traces, but it's going to be the same concepts. It's going to look the same as the midterm. Sword did not take any parameters. So even though Sword has 3 instance variables, it takes no parameters in the constructor. So there's nothing in this stack. That's a very common mistake. I set this up while I was live coding just so I could talk about that a few extra times. If it's not in the stack frame, if it's not in the method call, it's not in the stack frame. Stop putting, those of you who do this, stop just putting all of your instance variables into the constructor. Once you do that, I know you don't know what you're doing. I know you're not actually tracing the code at that point. I did consider it a minor mistake, but so we have the super constructor, but you're definitely missing some understanding there. This is the same, and weapon takes 3 constructor parameters: X location, Y location, damage. I gotta figure out what to adjust in lecture. I think there's something I can adjust in lecture to get rid of that. So it's too common of a mistake to just chalk it up to the students not paying attention. I think I got to do something a little different. So weapon takes all 3 of these. Weapon is going to call the super constructor. Super constructor here is game item. This is still the same. Don't do it. Do I still have audio? Don't do it. Do I still have audio? Okay. I bumped my mic and then I heard you connected a new device, so it disconnected and reconnected. So game item is going to take X location, Y location. Which is 0, 0, 0, 0. So we just forwarded those X location, Y location from the weapon constructor, which was 0, 0, 0, 0. And then finally we have some code to execute. This dot X location equals X location, Y location equals Y location. This returns. Weapon is going to say this dot damage equals damage, which is 30. Then return. Then goes back to the sword constructor, which returns, which again, I forgot my return arrow, but not permanently, as long as I get it in there. Still counts, count it. And then returns back to the main stack frame. Okay, so then we have p1.pickupItem. p1.pickupItem, we're calling it from this object right here. Pick up item from OX100. That's called from a player object, so I'm looking in the player class and looking for pickup item. The parameter is item. And the argument is potion, which is OX300. Now, pickup item takes a game item as a parameter, and what we gave it was a health potion. Since a health potion is a game item, that's a valid method call. Everything's perfectly fine with that. So we're executing the code. Hey, what's up? So this dot inventory dot add, we're adding to this array list, so it's going to be at index 0, the value item, which is OX300. And return. Shreyash, what's up? Pickup item, we're going to do it again. This is OX100 again. And we have item, which is weapon, OX400. That's not right. OX400. So weapon is a game item. It happens to actually be a sword, but it's a game item, and we call pickup item, which takes a game item, so no controversy there. And this assignment was fine because a sword is a game item. So this dot inventory dot add. So at index 1, we're going to put the value OX400. Okay, and now the big one, use all items. This is the one we're building up to. It's just always a lot of setup for any OOP example. Just a lot of setup to get where we're going. Oh, by the way, I didn't mention this in the other lecture. I forgot to, but this is our last trace of the whole semester. And for those of you who got at least one OOP and one data structures on the midterm, y'all don't care anyway. But this is the last trace. I'm not going to do a graphs trace because even during the spring and fall semesters, we don't have we don't do tracing quizzes for graphs because, well, reasons I won't get into it. And I do like to do the trace for polymorphism, even though it's not on a quiz in the summer, because I think it does show how polymorphism works. It's useful to actually see how this actually works in the code. Okay, so we're on get all items. This is OX100. I don't have a variable with the name OX100. So use all items called from a player object. So use all items right here, and we have a loop. So we're going to iterate over our game items. This was by far the most common mistake. Did I already talk about that in this lecture? The two lectures blend together too much. I think I did in this lecture. We're going to add a code block with item. Yeah, this was code blocks aren't stack frames. Yeah. But this was by far the most common mistake. It's common enough, and I was honestly anticipating it because every semester it's extremely common, which when that happens, that's my fault. I just got to change the way I lecture it. It's a minor topic, so I'm not that concerned that that understanding is missing, but it's still something I can improve in the future. I might promote it to a learning objective next semester. I don't know. I don't know if it's worth it. I don't know how much I care if you understand code blocks, if you understand inheritance, node-based data structures, can trace recursion. When you can trace recursion going through a tree, I don't know how much I care that you missed a code block, that you missed the whole point that left answer and right answer actually get removed from memory when we hit the end of that code block. I just don't know if I care that much. It doesn't really affect your code. It doesn't really make you a stronger programmer, the fact that you missed that. So that's what I struggle with. I'm like, do I really care? Do I want to devote more lecture time earlier in the semester? Do I want another quiz that just assesses code block understanding? I don't think so. But just a refresher, since this is a code block, and for for loops it's kind of a special case where this variable is declared in the code block, any variables declared inside a code block have to go inside this dashed box for the code block in your memory diagram. And then we get item.use of this. So we have, let's get what we know. We know use is being called through item.use. So it's being called through this object at OX300. So this is OX300. This stuff I care about, like references, and y'all kind of crushed the references on the midterm. I was happy to see that. So if I don't get my code blocks, but you're understanding references, hell yeah, I'm calling that a win. So use this of 300. We got to figure out what method is being called here. We know the argument, so let's get the argument. Let's get everything that we know. The argument is this from the use all items stack frame. Use all items, this is OX100. So OX100. But we have to find the method. So use was called by OX300. And to find the method, here's the trick when we have polymorphism. The trick is that there is no trick. It's the same exact way we've done this from classes to inheritance and now polymorphism. Same exact thing, and I'm very careful in lecture to always do this the same way. So when we get to polymorphism, you don't have to unlearn anything and relearn it. You don't have to change anything. You just do the same thing. Oh, I'm covering up a little bit of the code. You just do the same exact thing we've been doing all along. You look at the type of the calling object and then go to that class. So we have the health potion object. We go to the health potion class. We look for a method called use that takes a player. We find it right here, and this is what we call. That's it. Same exact thing we've always done. I have never, ever, ever, where we use all items. I've never, ever, ever gone to the code and looked at the variable type. I don't talk about variable types at all when I do traces. We don't mark the variable types at all when we do traces. None of these variables have types. The only thing that has a type are the objects on the heap, because those are the only types that matter while your code is executing. The rest of the types, all of your variable types, only matter during compilation, which if you're doing a memory diagram, you're already past compilation and you're at runtime. So the variable types do not matter in the sense that they have no effect on how your code executes or what happens in memory. It has absolutely no difference to it. So even though this use method is being called through a variable of type game item, all that determines is whether or not this code will compile. Is this a legal method call? The use method is part of the game item class, so that's a legal method call. We good. That's it. Oh, I pointed to the wrong one. The one that takes a player. That's it. That's all we need. And we're good. So this code compiles. So the game item type here already did its job. And now when we actually call the use method, we are always looking at the type of the calling object right here. I always highlight this when we have this situation in class. I highlight this and then go to that class and then find the method. And if we don't find the method, we go to game item. These methods are abstract, so that's not going to come up in this situation, in this trace. But we would continue our search. If we don't find it, continue our search in the superclass and then use that version of the method. Here we find the method, so this is what's being called. So we finally have the parameter player. And player.setHP, player.getHP plus this.potency. We have to resolve what's inside the parentheses first. So getHP is going to go on the stack first. GetHP was called through player. Player is OX100, so player dot, calling it through this object. So this is OX100. And then getHP is going to return, oh, I like my this dot. This dot HP. This dot HP is 40, so this is going to return 40. And this is where in a trace I would do this, I would set this line up differently. I would have this be stored in a variable and then call setHP with that variable, because then it gives me more partial information. We don't do partial credit in the course, but when I'm determining if you completed the learning objective or not, the more information I have, the better. So there were students on the midterm who got the wrong output, like the wrong thing printed to the screen after going through a whole tree traversal, for example. But there are enough intermediate values that I have you put on that trace that I was able to look at their whole trace and not decide, but see that they did traverse the tree properly, which was the learning objective, but got the wrong answer, and that's fine, whatever. You traversed the tree properly, that's what I wanted to see. There was enough information for me to see it, pass. In those situations, usually it was, I had a few students who read greater than as less than, but there was enough information to clearly tell that that's what they did. They just saw the symbol backwards. Simple mistake, who cares? You traverse the tree properly, that's what I want. But there were also students who got the right output, printed the right thing to the screen, but like skipped half of the variables in their stack frames and just had a very incomplete trace to where I couldn't tell if they actually could trace the code, if they traversed the tree properly, or if they pasted the code into IntelliJ, ran it, saw what was printed, and then put that as their final output, and then just kind of smack some crap onto their trace. I suspect that happens sometimes, especially when somebody asked during the exam if they could do that. Like, I know y'all are doing that. So I need to see all the intermediate values. So I would split this up. So, but I made this hard on myself for lecture, so I gotta think a little bit. So get HP returned 40 plus this dot potency. So in the use method, this dot potency is 100, so we're at 140, and then we're going to call set HP with 140. So set HP, like if this were a trace, I wouldn't be able to get to see any of those intermediate steps, and it'd be a lot tougher to grade. If you get the wrong output, I wouldn't be able to look and see if you had the right workflow, the right process, and I would just have to call it a 0. But with the intermediate steps, so for those of you, I'm basically justifying those of you who are like, man, why is he creating all these variables? It's just extra work for me. It's so when you make little mistakes, I can still tell if you did it right and still give you credit. So set HP is going to take set HP called through a player, set HP. HP is the variable, both lowercase letters this time, and 140 was the input that I just had to remember. And it's going to do this.hp equals math.min. Min is internal to Java, so I don't have to trace it. This.maxhp, this.maxhp, which is 40, and HP, which is 140. The min of those is 40, so this.hp equals 40. This.hp equals 40. It is a reassignment, so we still cross it out, even though we're writing the same value. This player's already at full health. They didn't need to drink that potion, but they still did. And we're back in the use method for the health potion class. This just ended, so this returns, and we're back into use all items. So use all items. I wish I did trim down this code. The scrolling up and down is, I know it gets it's just visually annoying, I guess. I don't even like it, and I'm the one doing it. So we get to the end of this loop, and then we're going to advance to the next value in the data structure, OX400, and then do it again. Item.use of this. So we have another use stack frame. This is going to be OX400. We did item.use from this object, OX400. And we know that the argument is going to be this, which is OX100. OX100. We don't know the parameter name yet, but we'll get there. We did this, so we called the method through a sword object, an object of type sword, and we're looking for use that took a player reference. So we're going to go to sword and find use that takes a player reference. We find it, so we didn't even have to go through our progressions. Otherwise, if we didn't find it, we'd go to weapon. If we didn't find it here, we'd go to game item. If we didn't find it there, we'd panic because we know it's not in object. So we found it right here. This is the method we're going to call. Our parameter is player. And we're calling player.set damage dealt to this.get damage. So this.get damage, we have a method call. We have to resolve the arguments first, or what's inside the parentheses first. So we're going to add a code block for get damage, where this is this, OX400. It was this dot, we called it from this object, so this is OX400, a reference to that object. So we're looking for get damage in sword. We're going to go to sword, look for get damage. We do not find it. So then we continue to the weapon class and look for get damage, and we do find it right here. So we find get damage right here. This is the one we're going to call, and it's going to return this dot damage, return 30. So this returns 30, which we're in use, swords use. This returned 30. So we're going to do set damage dealt, another situation where I'd split this into 2 lines for a quiz. Set damage dealt. This is player dot, so from this object, OX100, set damage dealt, in the player class, set damage dealt. Damage is the parameter, and the argument is 30, which I just had to remember. The damage of the sword. Okay, set damage dealt is just a setter. So this dot damage dealt is going to be 30. This returns back to the use method. That use method is done. This returns, and when we return, remember the crossed out stack frames are removed from memory. They do not exist anymore. So when a stack frame returns, we go back to the next non-crossed out stack frame. Use all items is the next stack frame that's still on the stack. So in this stack frame, we advance through the for loop, but there's nothing left in inventory. So this code block is over. Item is no longer in memory. Then we hit the end of the method as well. Method ends, goes back to the next uncrossed out stack frame, which is all the way up to main. Main just did use all items, so main is over. And we're at the end of that trace. Which actually ends the 11. No, this goes to 1:30, right? Which actually ends the content that I want to cover for this lecture. We actually ended early in the morning lecture. So I want to open this up. If any of you do have questions, if there's something you want to see, like this is the one lecture that does actually fit in the summer structure. And get everything in, which maybe for what am I saying? I'm trailing off. Maybe for spring and fall, I should just add more polymorphism content. Just change the course. Because students always complain when there's a break or we end lecture early. They're like, come on, professor, I just want to learn more. Give me more homework too. Never, ever has that ever happened. But if you have questions, if you want help with some, I already went over the homework. That I said everything I wanted to say about the homework at the top of the lecture. We did polymorphism. We rewrote all the code from the inheritance week. We rewrote it all to use polymorphism, explain what polymorphism is, did a memory diagram using polymorphism, told you how cool polymorphism is. Got everything I needed to say out there. It's kind of a chill lecture. It's a lot of pretty dense content. Like polymorphism it can be tough to wrap your head around at first. At its essence, it's straightforward, but when you talk about how and when to use it, it does get trickier. But at the same time, to finish task 7, you don't have to understand that either. Task 7 pretty much just walks you through it and says, put songs and movies in a data structure of type rateables. There's one thing I did think of. Oh, yeah. No, I can't do that, though. All right. So if there are no questions, I'm just going to end lecture early. But if there are questions, we do have till 1:30. So if you want to take advantage of 40 minutes of bonus content. But I told you everything I need to tell you to get test 7, so I'm good if you're good. But if you got questions, I'm more than happy to talk for another 45 minutes. I like talking. And I like explaining computer science stuff. So I took this job. So I'd be happy to do that for another 45 minutes. Wait, 45? Oh, 40. 41. But if there's no demand, I'm just going to end stream. I assume you're all pretty exhausted at this point. We're at the end of week 5 of a 6-week semester. I assume no one's going to complain. Except me. I kind of wish somebody out there wanted to learn more things. I'm sure you do, but maybe you just don't want to ask a question. But I'll give it another minute. Is there something else I want to say about Task 7? I don't think so. I think I said it all at the top. Task 7 is a pretty straightforward description. It's populate library, which is calling your Task 6 methods. Don't overthink populate library. Populate library is straightforward. It's just being on the other side of your Task 6. You wrote all the methods, you did all that work for Task 6, and Task 6 really is just setting up Task 7 so we can do populate library and have some actual data in our Task 7 code. And then top K ratables. This is where you're doing some work, which honestly isn't that much work. It's sorting and then grabbing the top K things. By the way, the time estimate for Task 7 is way lower than the task that came before and the Task 8 that comes after. I think Task 7 is a low point on the difficulty curve, so it does give you a bit of a break right after the midterm. So don't miss your Task 7 expected deadline. If you're looking to get another expected deadline, make it Task 7. This one's fairly straightforward. And then Task 8 is a little tougher, but also Task 8, I walk you through how to do Task 8 in lecture, like pretty closely. Task 8 will actually be the one lecture. I think I said this during the first lecture, if y'all remember that far back. I clearly don't, because I don't remember if I said this or not. But if I didn't, I meant to. Task 8 is going to be the one lecture where I will do slides in this lecture. In both lectures, I'm going to do the slides, because I don't have another way. Like, there's really no other way that I can cover that content. I don't know how to do it with live coding, because the whole point of the lecture on Tuesday, the graphs lecture, is that I'm showing you how to do Task 8 by showing you the approach that you should take. And I basically walk you through exactly how to do the assignment, and I do everything but show you the code. So I can't do that as live coding, because then I'm literally just giving you the solution. And I'm not about to do that. You're going to learn a lot less if I just give you the answer. But I basically give you the answer, I just do it in slide form and explain everything that you should do. If you just listen to that lecture and turn what I'm saying into code, that's what I'm asking you to do for Task 8. I think it's super easy, but students historically disagree. Like, Task 8 historically gives students some trouble. Okay. And then, testing. Testing, use your structure, your idea of testing files from Task 6. Do the same thing, call populate library with 3 files from your data directory. And then call top K ratables and make sure you get the top K ratables that you expect after manually computing what the top K are based on their Bayesian average rating. And don't do 2 songs or movies that have the same Bayesian average rating. I'm not going to test for that. You shouldn't test for that. Let's just leave that undefined and not test it. Because that would make the assignment just a lot more tedious without showing you more about polymorphism. It would just be extra stuff that has nothing to do with the learning objective. The purpose of this assignment's existence is to help you understand polymorphism, and this would not help you understand polymorphism if I have you write a bunch of extra logic, and the biggest tedious part is writing the extra test cases, that handle ties and Bayesian average rating, especially when you have truncation errors and those might not actually be ties. Then it gets like you got to handle all those cases, and it's kind of a pain. Not the biggest pain, but it would just be extra stuff that you'd have to do. All right, no questions. I rambled for a while to give you time to ask questions. No questions? I'm out. All right, see everybody. See you Tuesday. Good luck on your assignments, and take care.